Hey everyone, today we're going to tackle something that can feel, overwhelmingly complex: the world of modern medicine. Our goal is to build a simple but really powerful mental blueprint that's going to help you make sense of it all. So, let's jump right in.
I mean, just think about it for a second. There are literally thousands of different medicines out there. The challenge we face isn't always a lack of cures, it's a lack of clarity. How do we possibly organize this chaos in our minds?
So, here's our plan. This is our roadmap for today. First, we're going to talk about how to make sense of all this medicine. Then, we'll do a quick trip through history. After that, we'll crack the body's secret biological code, which then lets us reveal the four main jobs that all medicines do. From there, we'll apply it all to your own medicine cabinet, and we'll finish up by looking at the big questions we still have left to solve.
All right, first up, making sense of it all. Before scientists could conquer disease, they first had to conquer the sheer complexity of it. And they did that the way we humans always do when we're faced with way too much information. They started putting things into groups. So let's start with the most basic building block. What is a medicine, really? Well, at its core, it's just a chemical substance that has a specific job to do. That job could be preventing an illness, maybe curing it, or just making you feel better by taking care of the symptoms. It's basically a tool with a very specific purpose. Okay, so how do scientists actually create these groups? Well, they have two main ways of looking at it. The first is by what's called its therapeutic effect, which is just a fancy way of saying, what does the drug do for you? Like, does it lower your blood pressure? The second and much more precise way is by its mechanism of action, which is all about how it actually works inside your body to get the job done. Now, let's hop into our timeline, because understanding medicine isn't just about what something does. It's also about where it came from. And the journey from, well, basically ancient guesswork to the precision we have today it's pretty incredible. This, right here, is something that's really easy to forget. For almost all of human history, from 99% of it, healing was based on tradition, a lot of trial, and a whole lot of error. Our systematic, scientific understanding of how medicine actually works, it's incredibly recent. And you can really see that journey laid out here. We started with plant-based remedies like chewing on willow bark for pain. Then a huge leap forward in 1804 when morphine was pulled out of opium, which for the first time allowed for exact repeatable dosing. Then the absolute game changer in 1928, penicillin, the world's first antibiotic. And now, today, we're in an era where we literally design drugs in a lab to target specific proteins, even the DNA of a disease. So, how in the world do these modern drugs actually work? Well, to get that, we need to learn a little bit of the body's secret language. It turns out there are a few core biological principles that are the key to unlocking how pretty much all medicines function. The first word we need to know in this secret language is receptor. Just imagine that the surface of every single cell in your body is covered in thousands of tiny, specific locks. These receptors are just sitting there, waiting for the one right key to come along and turn a function on or off. And that's exactly what so many medicines are. They're basically custom-made keys. Their chemical structure is designed with a very specific shape to fit into a very specific receptor, that cellular lock. And they can do one of two things. Either they turn it, starting an action, or, just as importantly, they can jam the lock, blocking anything else from getting in and starting an action. The second really important term is enzyme. Enzymes are like the body's little factory workers. There are proteins, and their entire job is to speed up all the chemical reactions that keep you alive, everything from digesting your food to sending signals through your nerves. So if an enzyme is a factory worker on an assembly line, then some drugs act like a supervisor, yelling, "Stop!" They get in the way and block that enzyme from doing its job. A perfect example of this is a painkiller. It works by blocking an enzyme that's responsible for creating pain-signaling chemicals. If the enzyme can't do its job, it can't make the signal, and you don't feel the pain. All right, now that we've cracked the code with receptors and enzymes, we can finally build our master framework. It turns out we can categorize almost any medicine you can think of into one of four clear work styles based on the job it's designed to do in your body. And this is it. This is our cheat sheet. First, you have the preventative style, which acts like a teacher. Think of a vaccine that trains your body how to fight off an invader. Second is curative, the assassin, like an antibiotic, which actively hunts down and destroys that invader. Third, you have the symptom manager, the blocker, like a painkiller.
It doesn't fix the root problem, but it stops you from feeling the effects. And finally, you have regulatory, the balancer, like insulin, which is designed to correct some kind of chemical imbalance in your body.
Okay, so this all sounds good in theory, but how does it work in the real world? Let's take this blueprint of ours and actually use it to understand the kinds of medicines you might find in your own home right now.
See how it all starts to click? Ibuprofen is a classic symptom manager. It blocks the enzyme that makes pain signals. Amoxicillin? That's a curative assassin, but it's so important to remember it only targets bacteria, which is why it does nothing for a cold virus. Your allergy medicine, cetirizine, is another symptom manager that blocks those histamine receptors. And even something as simple as an antacid fits right in. It's a regulator that chemically balances your stomach acid. Now, our map, this blueprint, is really powerful, but it's not complete. So to finish up, I want to look at the frontiers of medicine, the places where our map is still being drawn and where the biggest questions are still waiting for answers. First, we have the truly terrifying challenge of drug resistance. You see, bacteria and other germs are alive, and they're constantly evolving to survive our assassin drugs. We are locked in a biological arms race against an enemy that is literally learning our playbook. The question is, can we stay one step ahead? Next up is the mind-boggling complexity of the human brain. I mean, it is the most complex object in the known universe. And that is why psychiatric medicines can be so unpredictable. They can work wonders for one person and do absolutely nothing for another. Our map of the brain, well, it still has huge areas marked "Here be dragons." And finally, there's the huge question of delivery. Look, it's one thing to have a powerful assassin drug that can kill cancer cells. But how do you get it to only the tumor without causing all kinds of collateral damage to healthy cells all over the body? Solving this targeting problem is one of the holy grails of medicine. And the answer, whatever it is going to define the next chapter in the story of healing.